Hi, welcome to our final project video for logic design course. Our project is an 8-bit integer divider unit design implement in VHDL code. Our group member is Buntalaksa, Vipat, Supapan, and our goal is to divide into unsigned 8-bit number using the repeated subtract algorithm. And here this is our basic logic, where Q is quotient, R is remainder, A is dividend, and B is a divisor. And this is our data part diagram. Here we have four registers A, B, Q, and R, and we also have marks here for the add and subtract. And this is our state diagram. Here we have four states. Here we have S0, S1, S2, and early stage. So for the S1 is like initiate stage. Put all the values and wait for S equal 1. Then S equal 1, you're gonna check again that if the divisor equals 0, if yes, you're gonna direct it to the early stage. And if divisor is not equal 0, then it's gonna be direct to the S1 state, which is the divine stage. So if R minus B is greater than 0, it's gonna do this logic, which R equal R minus B and Q equal Q plus 1. And it's gonna do it over and over again. If and only if R minus B is less than 0, it's gonna like to done. And it have to wait for the S equal 1 again to reset the system to the state 0. If not, it's gonna stay in the state done. So next part is our main VHDL file code. So for the entity definition, so we use the generic data with integer equal 8 to support 8-bit input, and we also declare bunch of port here. Clock reset S A B Q R done error. And for the state signal here, we got rtemp, btemp, qtemp, and also we store the SFM stage in the current and next state. We also have the CO, check, and comparator here. Wait, let me find that. Okay, here with the condition of B0 less than 1 when B equal to 0. Okay, that's detect divide by 0. And another one we use to control the division loop in the state 1 that I mentioned before. And for the reset process, on reset, all internal registers are clear. And on clock edge, btemp is already updated from B. Rtemp and qtemp are conditionally updated if enable, RE, RQ. Also, the RSEL decider R is loaded from A or R minus B, and QSEL decider Q is loaded with 0 or increased by 1. And here this is code for FSM process. For the output assessment, final value of Q and R are always updated as output signal here. So let's take a look at the test bench final. So this code is kind of messy, and I already computed waveform here. So let's look at the water cap in the report, so we can save a lot of time here. So this is test number 1. We're trying to do 10 divided by 3. It's will equal to 3 with the remainder of 1. So this demonstrates the normal division. And for the second test case is 20 divided by 4 will equal to 5 with the remainder of 0. So as you can see, it's perfect division. Only Q here and no R. and also no error. And for our third test case is 15 divided by 0. So as you can see, there's error here because it tests the division by 0 when it should rest the error. And our fourth case here is 7 divided by 2 equals to 3 with the remainder 1. Here's a test for division with the remainder. So as you can see, we successfully implemented a modular FSM control integer divider, fully completed VHDL code verified with realistic test case, support 8-bit unsigned division, and handles divide by 0 errors. That's all for today. Thank you for your attention. Thank you.